Let us proceed now for obtaining the differential equation for family of curves. Example, obtain the differential equation of the family of lines through the origin. You have the family of lines, and then passing through the origin. Okay, think of an equation that you're going to use according to the given. Okay, we can use y is equal to cx. Okay, since we have one constant, we can get for the y prime, okay, using the elimination of arbitrary constant. Okay, differentiate, we have y prime is equal to c. Substituting the value of your c to y equal to cx, we have y is equal to x, y prime. Then we have y is equal to x dy over dx. Cross multiply, we have y dx minus x dy equal to 0. Okay, I transpose the equation from the right side to the left side. That is the reason we have y dx minus x dy equal to 0. Note, the differential equation y dx minus x dy equal to 0 has the equation y equal to cx as its solution. Okay, for the figure, we have y-axis and x-axis. There. Okay. For the figure, we have passing through the origin. Okay. Next problem. Obtain the differential equation of the family of circles having their center on the x-axis. Now, the family of circles centers on the x-axis. Think of an equation that we're going to use. Since this one center of the x-axis, okay, we have x minus h squared plus y squared equal to r squared. Now, from the given equation, we have two arbitrary constant, h and r. Therefore, we have to get for y double prime from the elimination of arbitrary constant. Okay, differentiate. We have 2x minus h plus 2y y prime equal to 0. The derivative of your r is 0. Okay. 1/2. Divide both members by 2. Okay, therefore, we have x minus h plus y prime equal to 0. Again, we have still the arbitrary constant, which is h. Get the second derivative. Therefore, this one is 1. Then, using the formula for ub plus y double prime plus y prime equal to 0. Okay, let us arrange this one. We have y double prime plus, for this one, you have y prime squared plus 1 equal to 0. Okay. Now, for the figure, remember center on the x-axis. We have y and x-axis. Okay. All the center is at the x-axis. Then, for the third example, obtain the differential equation of the family of hyperbolas with center at the origin. Center at 0, 0. Therefore, let us use the equation x squared minus y squared equal to c. We have only one arbitrary constant, which is c. Differentiate, we have 2x minus 2y y prime equal to 0. Divide both members by 2. We have x minus y prime equal to 0. You have x minus y dy over dx equal to 0. We have x dx minus y dy equal to 0. Okay. For the figure, y-axis, x-axis. Okay. Again, center at the origin for the parabola, for the hyperbolas. Correction. Lying on the origin. Okay. Wait. Okay. Okay. Next. Find the differential equation as the equation representing all ellipses having its center at the origin and transverse axis x. Okay, again, think of an equation that we're going to use. Okay, we have x squared over a squared plus y squared over b squared equal to 1. Okay, differentiate, we have 2x over a squared. Remember that your a and b are arbitrary constant. Plus 2y, y prime over b squared equal to 0. Then, divide both members by 2. We have x over a squared plus y prime over b squared equal to 0. Or x over a squared equal to negative y prime over b squared. Let this one as your equation 1. By differentiating again, your equation 1, we have 1 over a squared equal to negative y double prime plus y prime all over b squared. This one will be your equation 2. Now, by differentiating again, we got your negative y double prime plus y prime over b squared equal to 1 over a squared. Now, dividing 1 and 2, dividing equation 1 and 2, we can get x is equal to positive y prime over y double prime plus y prime squared. Okay, then cross multiply, we have x y double prime plus y prime squared equal to y prime. Okay, therefore, we have x y double prime plus y prime squared minus y prime equal to 0. Then, for the equation, center at the origin for the ellipses. Okay.